do a short motivational video. It's going to be called, Why Are We Doing Surface Integrals in the First Place? Because we just covered surface area, and now what we're going to do is we're going to use surface area, and we're going to evaluate integrals that look like this, f dot ds, where ds is just the usual unit normal vector, and it's going to be multiplied by the surface area element, and f is just going to be some vector field. And you might be asking, quite rightly, why do we need more integrals? Isn't surface area good enough? Well, this is all trying to build up to doing a fundamental theorem of calculus in 3 dimensions. And in fact, there's going to be 2 of them. One of them will look like this. It'll look like a triple integral of the divergence. It will actually correspond to a surface integral of f dot ds. And there'll actually be another one, because whenever you go to higher dimensions, there's always more stuff. And if we use the divergence, surely the curl has to show up too. So this will be a surface integral over the curl, and this will correspond to a line integral of f dot dr. So first of all, let's just notice the parallels here. We have scalars, so that means one function on both sides, right? So if we have a vector field, that means somehow there has to be a dot product. There's that del dot f, and then there's that f dot ds. And we see there's a dot product, again, with the curl dotted with ds. And we'll also have a dot product on that right-hand side. And so aesthetically, I think these theorems are rather nice, and they're also quite significant, because they, I think most of the physical applications in reality will be using these theorems quite extensively. And if you even are wondering, well, remember in 2D, we had 2 types of integrals, right? We had line integrals, and we also had these work integrals, right? So this was like an arc length integral, and this was a work type integral. You could actually do something similar, and you could have considered f d capital S. And so something like this would show up if you do like centers of mass. For example, you could take the integral of z ds, and you could find x bar, y bar, z bar. But I think it's more expedient to not talk about these in this course and to just focus on these ones, because these ones show up just that frequently. So stick with me. It's going to get interesting.